So we're picking back up where we left off last time in section 7.4, looking at percent. And in particular, we had gotten to the point in this lesson where we're going to take a look at interest. That's the last thing that's going on here in our section of material. Hang on. What slide are we on? Not that one, this one. There we go. All right, so some vocabulary, some definitions first. Interest is defined to be the amount of money that you pay or you earn to borrow or lend money. Okay, it's how much you get paid if you are, how much you pay, if you are borrowing money, or how much you earn if you are lending money. Principal is the original amount that it's used to determine the interest. So in particular, it's the amount that you invest into that account or the amount that you borrow. The interest rate is the percent that's used to determine the interest. And then our book actually looks at only one type of interest. There's more than this. There's at least two others. But they look at simple interest only as being an elementary and middle grades core idea. So simple interest is defined to be the following. So A is the amount of your interest. It's equal to P, the principal, plus the principal times the rate times the time. Or this is another version of that same formula. It's not a different formula, it just looks different. So it's A equals P times 1 plus RT. And the interest part is actually right, hang on, here showing up. So the interest, PRT, is part of the formula for finding simple interest. It's this piece right here, A equal PRT. A few details, you've seen these before, but just as a reminder, P is the principal. R is the interest rate as a decimal. So we can't have it in percent form, it has to be in decimal form. And T is the time in years. So if somebody gives you something and it's in months, we have to turn it into years in order to use that as the T value in this formula. And then A is the amount of interest as in a dollar value, right? That's what that's coming out to being. So we're going to do a few examples of this and some related ones to this. The first one we're going to take a look at is a company. So a company is expanding its line to include more products. To do so, it borrows $320,000 at 13.5% annual simple interest for a period of 18 months. How much interest will the company be charged? So the fact that it has listed simple interest means that you're going to use one of those simple interest formulas. Specifically, it just asks how much interest. Not how much will they pay when it's all said and done, but how much interest will they be charged. And the formula for interest was the last one that we were given, which was I-E-P-R-T. So if you're looking for just interest, which this problem is, that's the only pieces we have to find. Okay, so P is the principal. Principal is how much we borrow or we invest. So what is the principal in this problem? $320,000. R is the interest rate as a percent, as a decimal, not as a percent. So our interest rate here is 13.5%. But what would it be in terms of a decimal for it? I know there's a decimal within that. That's not what I mean. What is the decimal value? Yeah. So remember we talked about this last time. We can move the decimal 2 to the left. We would get 0.135. So that is the rate that we have. And the time, T, is supposed to be in years. But they tell us that we have 18 months. So T is 18 months, but I need to turn it into years. What would that be in years? That's 1.5 years. So the 1.5 is what goes into this formula. Okay, grab a calculator. What does this give you for the amount of interest that they will be charged for this loan that they have taken out. I'm going to put a dollar sign. It's definitely going to be an amount of money, so we can put dollars on there. And we're working with money, so whatever the value is definitely needs to be recorded to 2 decimals or no more, right, if there's any decimals involved at all. How much money are they charged in interest? $64,800. Okay, do we agree with Aubrey? Yeah? Me too. $64,000 in interest and $64,800 in interest for doing this. Okay, now what could we do if we were asked to find this and we found this, and then we looked back and then we were like, oh shoot, it didn't ask me to find interest. It asked me how much money they were going to have to pay in total when we're done. That's okay. We can just take this amount and we can add it to what we borrowed, right? You got to pay that part back too. So if we wanted to find A, that's not this question, but if we wanted to find it, we can simply take the $320,000 we borrowed and add it to the $64,800 that we're paying back in addition to, and this would be our total amount of how much we owe back for the loan. Okay, so these are very related ideas. You can get from one to the other very easily. Just make sure you're paying attention to what the question is that's being asked. Okay, so I'm told a question very similar to this one actually showed up on a teacher licensure exam not too long ago, just FYI. So we're going to take a look at this one. I think it's a really good example of a place where it feels like there's not enough information, but we can work with it still, okay? So because of a recession, the value of a new house depreciated, that means it went down in value, 10% each year for 3 years in a row. Then for the next 3 years, the economy began to recover and the value of the house increased by 10% per year. And the question is, did the value of the house increase or decrease over the 6 years? So it may feel like that the answer is neither. It went down 10% 3 times, it went up 3%, 10% 3 times. That balances out. It's about the same. Maybe it's exactly the same. And that is intuitively what we look at this and think is happening. We need to verify that that's happening, or if not, why not? Okay? So while it doesn't tell us the value of the house, it doesn't have to. It doesn't matter what the value of the house is. The answer is going to be the same no matter what. We just get to pick the value of the house. Now, for the sake of it being nice and clean math, I'm going to choose a nice whole number, nice round number, even easy number to work with, that may or may not be reflective of true house values now. Are you good with that? Okay, if you don't like my value, pick a different value. You're going to get the same answer in the end that I do. I'm going to choose $100,000 for a house. Not saying that they don't exist, but you may not want one that costs that much these days. Okay, so we're going to assume a $100,000 house. Okay? It doesn't matter what we assume. So we need to pick something. Okay, for year 1, it goes down 10% in value, correct? Okay, so one of the ways that we looked at finding 10% is we looked at them in terms of proportions, and we could do that here as well. This one actually works really nicely because it's 10%, so I'm going to show you another option on this too. So we can take our $100,000 house, so this is year 1, our $100,000 house, and if it goes down 10% in value, how much does it retain in its percentage of value?
10,000.
Not the value, that's how much value it's going to go down. How much does it keep?
13,000.
Okay, it keeps 90%, right? Okay, so 90% as a decimal is 0.90. So it lost 10%, it keeps 90%, so I'm going to use 0.90. Does that make sense? Now, yes, you could find the 10% and subtract it, but I'm trying to do it all in one step, which makes it nice and friendly for our work. So what is 100,000 times 0.90? Close. 90,000. Yeah. So we've got $90,000. So this year the house is worth 100,000. Next year it's worth 90,000. That's what this is saying. Okay. But this is only going to happen, this is going to happen not only 1 year, but for 3 years. So we're going to do it again. Now, when we do it the second time, we're not starting with the value of a house that's 100,000 anymore. Now the value of our house is 90,000 to start with. So we've got a $90,000 house now. It's still going to retain 90% of its value, but it's not going to become 80.
It's gonna become, so you're taking basically.
81. Yeah, Emily's right. 81,000. Yes. So now it's worth 81,000. So the first year it went down 10,000 because that's 10% of 100. The next year it only went down 9,000 because that's 10% of 90. I mean, that's what's happening here, right? It's going down less, but it's still going down 10%. Okay, so let's try year 3. Year 3, now the house is worth 81,000. And it's again 90% of its value from the year before. The numbers get a little less friendly with this step. How much is the house worth now? 72,900. Okay, pretty good so far. Okay, so after year 3, according to what we've been given, the values are starting to rebound. They're coming back up, and now they're going up by 10%. So in year 4, we're starting with a $72,900, and it's going up 10%. So before, I used 0.90 because it went down 10%. What do you think I'm going to multiply by to represent that it's going up 10%? Nope. Keep thinking. Yep, Bailey's right. It's going to be 1.10. So let me explain why. So it was 90%, right? So that turned to 0.90. Now I have 110% because it's 100% plus 10% more. And this turning into a decimal turns into 1.10. And if you don't want to use the trailing 0 on there, you can leave it off. You could just use 0.9 and 1.1. That would be okay. All right, so after year 4, we have 72,900 times 1.10. What do we get? 80,190. We're going to do this for year 5. So in year 5, we now have an $80,190 home, increasing 10%. Where does that bring me to? Yeah, and we'll at some point here we're going to get some decimals. Let's just round to whole numbers. It's fine. Okay, 88,209. And then we have year 6, 88,209 times 1.10. What do you have?
You're gonna get $97,030 if you round up.
Yeah, so if we round, yeah, so $97,030. Okay, so this is where we started. This is where we're ending. Did the value of the house increase or decrease over the 6-year time frame? It decreased. And it doesn't have anything to do with starting at 100,000. If you'd started at a $1.5 million home, we would have had the same result. At the end, it would be worth less after 6 years than it was originally. Now, the second question also will still work even if you started with a different value of home. This question wants to know by what percent did it increase or decrease over that time frame. Okay, so this I am going to set up the way we did before because it works very nicely. When we're looking for what percent something changed, we learned last time that we can put an X over the 100 to find the percent. Do y'all remember doing that? Okay, so the number on bottom, the 100%, has to correspond to the original price of the home. And what did we pick? $100,000. If you picked something different, yours would go in there at a different plate, at a different value. The top wants to know how much did it increase or decrease. So let's go back over here because we identified that it did decrease, but not by how much. So it started at 100,000 and it went down to 97,030. How much did it decrease by? Okay, so what do we get when we subtract here?
2,970.
Yep, 2,970. Okay, is that okay? 2,970. Again, if you used a different than $100,000 house, your answer here is different, but it's going to come all out in the wash here in just a second. So we've got our 2,970 right here. And we're going to cross multiply. So we have 100,000 X equals 2,970, and then 2 more zeros since we multiplied by 100, so 297,000. And if we divide by 100,000, we get 2.97%. And we will get that same percent no matter what value house we started at. It will be 2.97%. That's how much it decreased, right? It was a decrease. It decreased by about 3% over the course of those 6 years. So the second question, part B, sort of levels the playing field. It's what actually shows you at the end that the answer percentage-wise that you get did not depend on the value of the house you started with. Okay, I have one more example in this section. It's not directly related to percent. It's related to, well, it's related to percent. It's not related to interest is what I meant to say. But it fits within this section. And I am going to show you a lovely example from COVID data. So I collected COVID data for a year, literally. I mean, data upon data upon data, because I thought, I'm going to be able to use this for something. So this is the result of part of that anyway. So as of August 1st, 2020, the total number of positive cases of COVID-19 in the state of Oklahoma stood at 37,731. The population of the state of Oklahoma as of July 1st, 2020, and I know that those dates don't match exactly, but they're the closest reported data I've got, so it's going to have to go. We're just going to be okay with it. Was 3,956,971 people. So the first question is, what percentage of Oklahomans had contracted COVID-19 as of August 1st? So we took a look at setting this up the way that we had done with our other percents, right? And we're looking for what percentage, just like on the last problem, so it sets up like that. I've got a couple of numbers given to me. What goes where?
37,731 over the population.
Okay, so that's what Wiley suggested. Do you agree with her? Okay, yeah. 100% is the number of people. The top is the number of people who had been positive or tested positive for COVID, and we're trying to figure out what percentage that is of the other value. Okay, so we're going to cross multiply. When we do, let's see, I have 3,956,971, and it equals 773,100. I think I've got my decimals in the right place, or my place values in the right place there. And, oh, I left off my X. My apologies. There's my X. And then I'm going to divide by the 3,956,971. Okay, when we divide, we're going to go with 2 decimal places of accuracy. What do you get? 0.95. And that's percent, right? Okay, so I mentioned this last time, but I want to give us some perspective again one more time. This is less than 1%. It's not 95%. It is decimal point, right? 95 hundredths of a percent. It's kind of like that penny. I did that in this class, didn't I? Talked about the penny? Yeah, it's like that. So this is less than 1%. Less than 1% of the population. Okay, so let's go and move on into the discussion of what that does in terms of children. So 10.92% of the positive COVID-19 cases were in children ages 0 to 17. Again, this isn't perfect data because what I really wanted to know was school-aged children, but it's hard to find exactly the data you want sometimes with statistics. It's close, okay? So let's say that these are school-age and daycare-age kids. We'll go with that. How many kids does this reflect? Well, this time I'm given a percentage, so that 10.92 has got to be a value that's over the 100%. And I'm wanting to know how many kids this represents out of the entire population of people who tested positive, right? Not the whole population, but those who tested positive. So how many people did it say tested positive?
37,731.
Okay, so 37,731 is the denominator. It's the positive cases. And I'm trying to figure out how many of those cases are actually children. So we're going to cross multiply again. I have 100x. So that we don't have to wait too long, I'll give you the number next. It's actually 412,022.52. That's what it ends up being. So 412,022 and then 0.52. And of course, we're going to divide this by 100. it up a little bit. And when we do that, if I round to a whole number of kids, because kids don't come in half numbers, right? Okay, just checking. I have 4120 kids. 4,000 kids, give or take, right? 4,120 kids had tested positive. So another data statistic. At the time of that census for the number of total people, which was 3 million, almost 4 million people in Oklahoma, 981,328 were kids. And we want to see what percentage then of the children had tested positive for COVID-19, right? We knew the overall percent was less than 1%, but what percent is it of the children? It's not necessarily the same, right? Different populations are affected differently. So again, we're looking for a percent. So this is the part we don't know. And we have our 100 on the bottom. Well, we had 4,120 kids that tested positive out of 981,328 children total. Okay, does this make sense so far? Okay, you cross multiply. I have 981,328x equals 412,000. I think that's right. We'll divide by our 981,328. And you have a percent.
0.42.
It's 0.42%. It's less than the number before, which was almost 1%, right? It was 0.95. This is 0.42%. And if you want to have some sort of perspective of what that's saying, this is saying that it's 4 out of every 1,000 kids. Okay? So if you were in a small school district, maybe you had, a high school or whatever, you had only 100 kids in your high school, or 200 kids in your high school, or 2,000 kids in your high school. You could still take this. So let's say you had 2,000 kids in your high school. If we were following this, it would have meant 8 of those 2,000, had been affected by COVID-19. And this isn't like they were affected on August 1st, right? This is cumulative from January to February when they first started collecting data all the way until August 1st. And we shut down schools for a really long time. And you guys are still suffering consequences from having schools shut down. We still see it. We still see it in the college level, those consequences of those decisions educationally.